design and implementation of half subtractor. The first we have to know the truth table. This is the truth table. A and B are the two inputs, and difference and borrow are the outputs. And from that truth table, we have to find a relationship of the difference in terms of A and B, and also borrow in terms of A and B. And for that, we'll be using the K-map. And here, you can see, here we are using the K-map here. And from the K-map, we found a relationship of the difference in terms of A and B. And difference equal to, you can see here, it is A XOR B. And again from K-map, you can see the borrow equal to complement of A into B. And that, from this relationship, we have drawn in the circuit diagram. You can look at that. We have drawn the circuit diagram. Therefore, here, DI equal to A XOR B and borrow equal to A complement into B. And therefore, we have to implement this is in the only with the basic gate. Therefore, XOR gate has been replaced with the basic gate that we will be implementing in the lab. For that purpose, we have to go to the lab. Let us come to the lab. We are realizing half subtracted in the digital IC trainer kits. First, we have placed here the AND gate in this slot, OR gate in this slot, and the NOT gate here. Now, first VCC and grounding we have to do. Therefore, VCC and grounding, this is the 14 to VCC, 7 to ground. It is same for remaining all the ICs. Therefore, 14 to VCC and 7 to ground. Here also, NOT gate also, it is the same. After doing it, after connecting this, then you come to that, we are going to realize this truth table. Already we mentioned about the truth table, we are going to realize that truth table. Now, after the designing, we got the design here. The difference will be is A exclusive OR of B and borrow equal to complement of A into B. And that the XOR gate I have shown, because from the XOR gate, the basic gate conversion is simple. Therefore, we are going to implement this circuit. Now, first in this, you can see here, you can see here that A's complement is one of the input to the AND gate. Therefore, I am coming to the complement of A. To complement of A has to be, this is the A, and complement of A I have to make with the NOT gate. Therefore, you can see again, you can see that I see the pin diagram. Therefore, there are 6 pins, and we are using at the first we are using that 1 is the input to the NOT gate and 2 is the output. Therefore, first is the NOT gate. Therefore, I am this is the A, and therefore I am giving the 1 to the NOT gate, and 2 is the complement of A. The complement of A will go to, you can look at that. This is the first topmost AND gate. It will go to the input. Here again in the truth table you can see we are taking this one. Therefore, 1 and 2 is the input. Therefore, I am connecting the 1 here. And then you can see the B. You can see the B, another input, and it is C directly it is connected to the input to the AND gate. Therefore, I am connecting to 2. Now you can see the 3. 3 is the output of the AND gate, and you can see from this 3 is the output of the pin diagram. 3 is the output of the AND gate. That has to be connected to the input to the one of the input to the OR gate. The OR gate I told it is the 7432 and of the same pins. And therefore, OR gate I will take, this is the OR gate, 1 and 2 is the input. Therefore, OR gate, one of the input is the 1, and therefore this part is over. Then I am coming to the second AND gate. There you can see from second AND gate, directly it is coming from A. Therefore, it is coming to the A. And now which one from the pin diagram I will take this. This is the another second one I will take. Therefore, 4 and 5 is the input. Therefore, I am putting into the 4. A I am putting in the 4. And another input is coming the complement of B. Therefore, B has to be complemented. Therefore, I use another NOT gate. Therefore, this 3 is the input, 4 is the output. Therefore, I will be using 3 is the input and the 4 is the output. You can see the B B I put into the 3 and 4 will be the complement of B, and that is the input to the second AND gate. Therefore, it is a 5. I am putting into the 5 of the AND gate. Output of the AND gate is, you can see in the pin diagram, output of the AND gate is 6. Therefore, 6 will be connected to the input to the OR gate. Input to the OR gate. Therefore, I am connecting the input to the OR gate. Input to the OR gate. This is 2. And then output of the OR gate. You can look at the output of the OR gate is the difference. Therefore, output of the OR gate is the 3, and that we have to connect to the output terminals. Therefore, we are keeping it here. Therefore, difference is here over. Now you are coming to the now you are coming to borrow. Borrow is the complement of A. The complement of A we have to make. Therefore, I am putting into the A. Therefore, I have to make the complement. Therefore, it is another NOT gate I am using. If the input is the 5, therefore you can look at the input is the 5 and the output is the 6. Therefore, NOT gate input is the 5, output is the 6. Output is the 6. Therefore, that has to be given as the input to the another AND gate. I will be using another AND gate. Therefore, another AND gate I will be using. This is the AND gate. 9 and 10 is the input. Therefore, I am putting into the 9. This is the complement of A. This is the complement of A is putting into the 9. Therefore, 9 is the 8, 9. And therefore, and another is coming from B. Therefore, B is directly coming to, I am giving to 10. And you can look at that is the 10. Therefore, I am giving to this B will go to 10. And you can see from the pin diagram, 8 is the output. And 8 is the output. Therefore, output is the borrow. Therefore, I am keeping the borrow here. And that is about the circuit connections. And then we will go for the changing of the inputs, and so you see the output. After the connection, we will see the truth table. Now you can see here in the truth table, A equal to 0, B equal to 0, difference equal to 0, and borrow also equal to 0. Here you can see A equal to 0, B equal to 0, difference is 0, and borrow also equal to 0. Now we'll make A equal to 0 and B equal to 1. Then difference also will be equal to 1 and borrow also will be equal to 1. Now we are making B equal to 1. After making B equal to 1, you can see here the difference equal to 1, borrow also equal to 1. After that, we are going for a third row. Now I will make A equal to 1, B equal to 0. I will make A equal to 1, B equal to 0. In this case, difference will be equal to 1, borrow equal to 0. Therefore, I will make A equal to 1, B equal to 0. You can see difference is equal to 1 and borrow equal to 0. Now, if both are equal to 1, A equal to 1, B equal to 1, then difference will be equal to 0, borrow also will be equal to 0. Therefore, if I switch on the B, that means if it make it 1, therefore it should be switched off. Therefore, both difference and borrow should be equal to 0. Therefore, this is happening. What should it happen? Exactly the output we are getting, and that is all about the half subtractor.